Hello guys, hope all of you are doing great. In this part of the video, we'll be talking about a while loop. Let's first see how do we write a while loop, and then we'll be going into the details of a while loop and we'll be using it actually to do some meaningful tasks. Okay, let's begin. So whenever you are using a while loop, what is the first thing that you'll be doing is you'll be usually declaring a variable and you will set the initial value of the variable to some value. Let's say we have a variable c and we set the initial value to be 0. And then you'll be writing this keyword while, and then you will apply a condition. You will check a condition usually on the loop variable, that is this variable that you have declared. Say for example, right now I'm checking the condition whether the value of c is less than or equal to 3 or not. This condition could have been anything, okay, or any condition. Right now I'm writing c is less than equal to 3 or not, okay, and after that you have to write this colon as part of the syntax. Once you do that, now you know after that you have to specify the body of the while loop. When I say body of the while loop, it means the block of code that you want to execute when the condition is true. So say for example, here I just want to write I want to display the current value of c on the screen whenever it is a true condition. See here, whenever it is a true condition, this body will be executed. So I want to display the value of c on the screen. Now see, one thing you have to remember here, after execution of this body, whatever the code that you write inside this body, that body will be executed once the condition is true. And after the execution of the body of the while loop, it will go back and it will check the condition once again. Now see, at this point, if you try to execute this program, think logically, what will happen? Initially, the value of c is equal to 0, yes, and then this while loop will be executed. As a result, it will first see whether the value of c is less than equal to 3 or not. 0 is less than equal to 3, that is a true condition. Since it's a true condition, based on the thing, or based on what I said you is the body will be executed, isn't it? So as a result, it will display print c, which is 0 on the screen. After that, again the control will go back here and it will check the condition once more. Now if the condition is checked once more, c is less than equal to 3 or not. Right now the value of c is again 0 because nowhere we have changed the value of c, isn't it? So for that reason, what will happen is 0 is again less than equal to 3 will be checked, and it will be a true condition, so it will again display 0 on the screen. Got the problem there? So once this 0 is displayed on the screen, again it will go back and will check the condition once more. And since we didn't change the value of c yet, the value of c is still 0, and 0 is less than equal to 3. Again it is a true condition, again it will print 0, and that way this loop will be executed again and again and again and again. This loop is an infinite loop. Now see, the point that you have to notice here is that the stopping condition, that is when the loop is going to be stopped, it is the responsibility of the programmer. Like, they specify the stopping condition in a proper way. It is not the responsibility of the Python interpreter. It is not going to stop the loop automatically, it is not going to do anything, any such things. So whatever you write, only that, and that way only it will execute the code. Even if you write a infinite loop, the interpreter will always, it will go on displaying the value of c, which is 0 on the screen again and again and again. So as a programmer, you have to write the code in such a way that at some point of time the code the loop terminates. You got the point here? Okay, so if you got the point, then say, and obviously whenever you're writing a reasonable program, you will always have some condition based on which you might want to stop the loop. Okay, so for that reason here, if you want to stop the loop and if you follow the logic, then we have to do something here that actually makes this condition false at some point of time. Okay, right now maybe we want to print the value of print the value within the range from 0 to 3. So in this case, let's simply increase the value of c by 1. But this condition could have been anything. It is not always it is not like always you have to write c is equal to c plus 1 or that loop variable is equal to loop variable plus 1. It is not the case. Okay, you might want to change the only thing is that you have to take care of as a programmer, that you have to write your code in such a way that at some point of time, whatever the condition that you write here, it becomes false, so that the loop terminates and the control gets out of the loop. You got the point? Okay, now whatever the block of code that you write here, it is actually what you say, it depends on the program that you are writing, isn't it? Okay, done then. So let's see now if we execute this program, then what will happen and what will be the output of the program. You can see 0, 1, 2, and 3 is coming on the screen. Why? C equal to 0, 0 less than equal to 3, true condition, print 0 on the screen, increase the value of C by 1, which will make C 1, 1 less than equal to 3, again a true condition. So print C, that is 1, and then increase the value of C again by 1, which will make it 2, and it will display 2, again by 1, 3, 3 is less than equal to 3, true, print it, and then increase it. At some point of time, C is equal to 3 plus 1, 4. 4 will be stored in C, and 4 is less than equal to 3. That's a false condition, so the loop terminates. Got a point? Now see here, the indentation, obviously you know by this time, right? It is, if you write here, say for example, print now after while loop, then based on the indentation, actually the Python interpreter will decide whether this particular line or this instruction is actually inside the while loop or outside the while loop. So if you don't give any indentation here, it will be assumed that this print statement is outside the while loop. So as a result, once the loop is over, then only this line will be executed. So you can see here the output 0 to 3 will be printed first, and then after the while loop. But instead of writing it in this way, if I write here in an indentation, then obviously, as you can guess, yes, along with each number, this line will also be displayed. You got the point? So that's about a while loop. Now you can use this while loop anywhere. I mean, wherever you want to use a for loop, wherever you can use a for loop, the same place there, the same problem you can solve using a while loop also. Okay, so today we'll keep our focus on while loop only. Okay, but the for loop also is there. You should know that whatever it is possible to do using for loop, the same thing you can do using while loop, and vice versa. So then you might be thinking, then why two different types of while loop, different types of loops are there? It's just variations are always there, isn't it? I mean, you know that, right? In our real world also, we have different variations. We have Twitters, we have Facebook, we have same thing more or less, but we have different variations there. Microsoft Windows is there, Linux is there. You got the point? Yes, right. Now let's write some other codes and see. Let's say, for example, you have a list and you want to display the content of the list using a while loop. How do you do that? Simple, right? We'll be using, again, it's more or less every time you're using a while loop, you'll be setting a counter to to some initial value, and then you will be changing the value of the counter in such a way that at some point of time it reaches its final value, and that time only it will stop the loop. Usually, okay, that's how we write a while loop. So whenever it is a while loop, you need a counter or you need a variable. Let's say C is equal to 0 initial value, but before that, let's declare a list and then store there these whatever the items that we want to keep inside the list. Say for example, some numbers 1, 2, 3, and then some strings, say 1, okay, 1, and then 2, and then 3, or anything you can store here. Okay, let me write here 3, three. Okay, and then what our goal is, we want to iterate over this list and we want to display the elements of the list one by one on the screen. How to do that? We have already declared the counter. Now what we're going to do is we are going to write the while loop. Yes, while, and then we have to check the condition. Now what condition should we write here? I mean, yes, based on these examples, you might say, okay, we have to write like C is less than or equal to something. But what is that something? One way is that, okay, you can count 3 plus 2, 6 elements are there. You can write here C is less than equal to 6. But it is obviously, it's not an appropriate solution because this list might not contain 6 elements always, right? It might contain any numbers of elements, and every time you do not want to count them. And, at some point of time, it might happen that this list is was initially not there, but it was actually computed dynamically, intermediate results. So obviously that time, knowing the actual length of the list is impossible for the programmer. So for that reason, what we'll be doing is, so let's declare a variable n and then use this len function I told you about in one of my videos most probably. So n is equal to len and then specify the list. So it will tell you how many elements are there in the list. So once we know that, instead of 6 we can write here n and then colon as part of the syntax, and then what we have to do is we want to print the content of the list. So we'll be writing, okay, whatever it is, the list L, and at index C, whatever it is, because you see here C is starting at 0 and it will be going up to n, not less than equal to n. I'm sorry for that, it is less than n. It will go up to n minus 1. Less than n means the last valid value for this loop will be n minus 1. And then if we increase the value of c by 1 every time, right? So then we are printing L of c. Whatever it is the value of c right now, at that index, whatever it is the element is there, we want to display it on the screen. And after that, to stop the loop at some point of time, we have to write here some code, right? So that at some point of time, this condition becomes true. This condition becomes false, right? Then only the loop will get out of, the control will get out of the loop. So for that reason, what we'll be doing is we'll be increasing, because we want to display all the elements one at a time, right? 0th index, first index, second index. So we have to increase. It is the demand of the, the program that we're writing, that we have to increase it by 1 every time, the value of c. C is equal to c plus 1, okay? And that's all. If we now execute this program, you'll be seeing 1 2 3 and then 1 2 3, as the content of the list. It is being displayed there, right? Now you know how to display the content of a list using a while loop. One small thing, let me tell you here. See, you might be thinking, is it possible to display the content of the list? Not like 1 2 3 1 2 3 vertically, but rather horizontally, okay, so that we can read them properly. Yes, it is possible. You can do some small tweak with this print function. What you can do is you can pass an extra parameter to the print function whose name is and, okay? And you have to write and is equal to some string here. So whatever the string that you write after printing, see here, basically after printing this, what is the next default character that you want to print? By default, that next character is /n, that is a new line character. So if I write something like this, it will print exactly the same, it will generate exactly the same output. But what you can do is actually you can change this default value to any value. So for example, here I write, after printing this thing, whatever it is that I ask the print function to print, it will print that thing, and after that automatically it will always print whatever you write in and equal to. So for example, I write here 8x8 for some reason, then you will see the output will be, see, 1 is printed and then 8x8 is coming because I wrote it that way. And after printing 2 also, it'll print 8x8. After printing 3 also, it'll print 8x8, right? So what we can do then, we can give a space here, right? If you give a space there, then what it will do, after printing 1, it will give a space. After printing 2, it will give a space. Sorry, after printing 3, it will give a space. That way. A small thing about print. Done? Okay, now if you have understood, see here, while loop, we are talking about while loop again, okay? So most probably now by this time, it should be clear to you what basically a while loop does, isn't it? So that much only. But the thing is that I wanted to show you people, using while loop, you can achieve some really good, you can really write some good programs. And it's really, you see, while loop, most of the times you have to, whatever the code that you want to write in any programming language, this loop is a very important, crucial, and very frequent feature of the programming language that you will be using in your code. Without loop, the concept of loop, it will be very much difficult to write any valid, any practical program actually that solves practical, real world problem, something, because loop allows you to do certain things repeatedly again and again and again and again based on just one, based on some conditions basically, isn't it? So it allows you to automate the process. Don't you think so? It just automate the process. You just set there a condition until and unless that condition is true, you ask the computer to do the same thing again and again repeatedly. So that's the power of a loop. Now let's write some programs and see this loop in action. Okay, so for that reason, what we'll be doing is, okay, let's say for example, now I'll be telling you some other things also. Now let's do this thing. Let's say, for example, we have to compute the value of sine theta. Okay. Now, don't worry, we are not going to actually get into the what do you call it, like computation, the computation process of sine theta. We'll be using a library, inbuilt library. Okay, we are not going to the actual formula that you use, to generate the value of sine theta, the factorial formula. Directly you'll be using a library. Okay, so for example, just let me come to the point. Say for example, you have variable theta, or I can call it anything actually. Let's say a is equal to some degree, 45 degree. Okay, and you want to compute the value of sine theta. You want to compute the value of sine on that particular degree. How do you do that? It's straightforward actually. You can do something like, there is an inbuilt library in Python. If you want to compute any mathematical function, then you have to import that library. Now you might be thinking, if you have not heard about it, then what is this import? Import in the sense like, importing, I mean, bringing something in actually. And see here in Python, there are some already pre-written code is there. Okay, so what you can do is you can include that pre-written code with the current code that you are writing, sort of. You want to, like, add some more code, already existing codes with your program. Okay, so that is in 1 or 2 lines this import function, this import statement does. Okay, so the point is that whenever you want to include want to use a mathematical function, what you will be doing is you will be importing the library, inbuilt library in Python, whose name is mat. Okay, so import mat, that's all. Now once you import mat, then computing the value of sine theta or any trigonometric function like sine theta, cos theta is very easy. Let's see how to do that. Say what you can do is you have to make use of this mat.sine. If you want to compute the value of sine, then you will be making use of mat.sine. And here within this bracket of this sine, you have to specify the angle, but you have to specify the angle in radians, not in degree. Here I wrote a equal to 45 degrees. So if you want to compute the value of theta, I mean 45 degree, first thing that you have to do is you have to convert it to radians. Okay, let's start with some examples, then we'll get into the details. So for example, we want to compute the value of sine, say sine 0 is 0, sine pi is 1. Let's compute the value of sine pi by 2 is 1. So let's compute the value of sine pi by 2, which is like pi is like 3.14. 3.14 divided by 2. I'm just starting with some initial values, and let's see what is the output first. Okay, so we store the value of this function, like the output, in the variable say O, and let's display it on the screen. Okay, print O. Let's see what is the output it gives us. A equal to 45. Right now we are not using it. The point, you see here the output 3.14 by 2, which is actually pi by 2 more or less, and sine pi by 2, as we know, it is 1, but it is not, the output is not exactly 1. It is like 0.9999996, which is like, if you round it off, then you'll get a 1. Now why this error is coming? Actually because of this inaccurate value of pi that I specified here. In the math library itself, you have a constant that you can use instead of pi. Every time you want to use pi, you don't have to write it like 22 by 7 or 3.14. Directly you can write mat.pi. It will give you a more accurate value of pi. And let's see here, if we specify this value accurately, the output will also become more accurate. You can see sine pi by 2 is basically 1. We know that, like sine pi by 2 is equal to 1. There is still, inconvenience in some way for some people, like who wants to think, who likes to think in degrees rather than radians. Okay, so for that reason, suppose we just want to specify like sine 90 degree. We want to specify the input in terms of degrees, and we want the output there directly. So you can do that actually. So you can, in the same math library, there is a function called radians that converts degree to radians automatically. I mean, yes, automatically. Basically, you don't have to write any code for that. You can write certainly some code of your own to convert degrees to radian, but you can use this radians function directly. Let's do both these ways. Okay, we want to convert a degree to a radians of our own. We don't need that inbuilt function. Say, so how we can do that? We know like 360 degree is 360 degree is 2 pi, 180 degree is pi, right? So if 180 degree is pi, that is mat.pi divided by 180 degree. So what did I do? Yes, mat.pi divided by 180 degree, and then we have to multiply that thing by the angle, right? So we'll be writing a multiplied by, and that is our radian, isn't it? So if it is the case, then let's make this a to be 90, because we want to see the output 1.0 here. So instead of writing here mat.pi by 2, we just want to write here radians, because it is same. Mat.pi is that is like 1 radian is mat.pi by 180. 1 degree is equal to, and then that many degrees. So ultimately it should give me again 1 as an output. It's 1, right? So instead of writing these things here, like, remember writing this function by yourself, what you can do is rather you can use this mat function, mat.radians. It will basically do the same thing that we did in this particular line. Okay, so mat.radians directly pass the angle, and now also you will be seeing the same output there. 1. You got the point? Now it's that simple actually, like to compute the value of any trigonometric function. Say for example, now you want to compute the value of cos theta. So you can simply write mat.cos, and then if you want to compute the value of say other functions like tan theta, then you can write here tan. You see here it is showing you cos 90 degrees 6 point something into 10 to the power minus 17. So it's basically 0. Okay. Okay, then what else then we have to do? Yes, I wanted to tell you actually, like say for example, you know now how to compute the mathematical functions. Say for example, sine theta for a given theta. Now say now assume the situation where you have to compute the value of sine theta for all these integer degrees, that is starting from 0 degree to 360 degrees. You want to compute the value of sine theta or maybe any function. Okay, I'm just using sine theta as a representative. Okay, let's see how to do that. We want to compute the value of sine theta for all these degrees from 0 to 360 degree, 1 degree interval. Okay, so let's start with these numbers. Say c is equal to 0 degree. Initially we are setting the counter to be 0, and then what we do is we'll be writing a while loop. While the value of c is less than or equal to 360 degrees, we want to go up to 360 degrees. Okay, so we'll be writing there a colon. See, this 360 is just a number. For the computer, it really doesn't bother it whether you are actually writing 360 in degrees or whatever it is. So your intention, whenever you're writing a program, you always have to explicitly mention. What I mean by this is, let's say, we want to now compute the value of sine c here, whatever it is c. So we want to compute the value of sine c. So for that reason, what we'll be doing is we'll be first converting this c to radians, okay? Because the sine function it needs the input to be in radian. So for that we'll be converting it to radian, and radian is equal to, so we'll be using again mat.radians, and then we'll be passing here c. So whatever it is the value of c, we'll be converting it to radians, and then we'll be computing the value of sine theta. Let's declare a variable sine, sin. It could have been any variable name, okay? So sine, and then we'll be using mat.sine. This variable name doesn't have to do anything with this sine function. Okay, let me change this. Is it clear if I write sine here? Okay, yeah. mat.sine, and then you have to specify here radians. Done. After doing this, what you have to do is you have to increase the value of c by 1 degree, because we want, in the next iteration, we want to compute the value of sine theta for the next degree. So for that reason, we'll be increasing the value of c by 1. Done. And that's all. And after computing this value of sine, let's print it on the screen. Print and then sine. And let's print them on a separate line. Let's see the output. Sorry, we are starting with 0 and we are going to 360 degrees. So sine 0 is 0, it'll go to 1, and then again it'll go to 0, it'll go to -1, again it'll go to 0, right? Is it so? Yeah, okay. So what it is doing is, let's see the output here. First, let's see the output. We'll do something on it again. See, it is going from 0 to it is slowly going, it is increasing. No? The value of sine theta is going up and up until and unless it becomes 1 somewhere it will become 1, yes, and then again it will start going down. Now see, whenever you are computing the value of a function and you see the values of the function in this way, seeing the pattern is not very easy, isn't it? Just by looking at the numbers, isn't it? So one better way of representing numbers to the to human is like plotting them in the form of graph. I'll be telling you that thing also in this video only. Don't I guess if you wanted to know only about while loop, then you can stop it and you can leave the video. But if you want to continue, let's continue, okay, for those people. Now see, we want to plot these values of sine theta in a graph. It's very easy, like that is my point actually. Doing things you just need to know few things and you'll be able to do lots of things. And you'll be able to write a very, like different types of programs just by writing few lines of codes. That's the power of Python actually. Okay, let's now again come to the point. Like suppose we don't want the output to be in this in a numerical format. We want it to be like in a nice graph. Then how do you do this? Doing this thing in Python is again very easy. For that reason, you have to use this library, obviously, and that library is called as matplotlib. Don't worry if you are if you're hearing it only, if you're hearing it for the first time, then also don't worry. It's just like few things that you have to remember, and once you use them, you'll be used to actually. Okay, very simple things. But very powerful things. Okay, so let's do it again. Import, it means we want to bring that library in with our code. Import matplotlib dot pyplot. That is how you actually import. For the time being, you can remember it that way. Yes, my pyplot as plt. It's just a shorthand name. See here, you are importing basically this library, but you are calling this library inside your code. You'll be calling this library as plt. That's all. Okay, it's just a name that you give to this big name. Instead of writing every time matplotlib.pyplot, you'll be calling it a plot. Nickname sort of. Okay, you can call it anything, by the way. Say you can call it say me, no problem. Let's start with this me. Keep this me, okay, so that you don't get confused. My point is that you can use actually any name here. That's why I'm using me here. Okay, done. Now once you import that, now plotting the graph, I'm just showing you how you can plot x versus y. That's enough for today. Okay, let's see how we can actually plot x versus y using matplotlib. You need x's and y's, isn't it? So let's compute these x's. Okay, x is equal to, you just write there. Okay, let's now do something like this. Okay, matplotlib, and this x is equal to, let's compute this same function, this sine theta function, but in a slightly different way. Okay, so what we do is, okay, let me copy this code just to save some time. You'll be seeing it in a moment. It's just c equal to 0 and c is less than equal to 360 degrees. So what we do is, along with the other things, we'll be declaring here two lists. Okay, we'll be calling one list as x and another list as y, and initially we'll keep both these lists to be empty. Up to this point things are clear, and then we'll get into the code of computing the value of sine theta. There what we'll do is, okay, every time you get inside the loop, then what we'll be doing is we'll be writing something like x.append. It means whatever it is the value of, that is, we want to append something at the end of the list. So whatever it is the value of c, we want to append it to the list x. X will be our x-axis. So 0 degree, 1 degree, 2 degree, 3 degree, those are our x's, isn't it? So that's what we are doing here by writing x.append c. And similarly, the output also against this x, against 0 degree, whatever it is the value of y, that also we want to keep track of, and that will be pushing it into the list y. Okay, so here instead of printing it now, see, instead of printing it, what I'll be doing is, I could have printed it also, no problem, but let's get rid of this print function. Instead of that, you just write there y.append, append, y.append, and what we want to push into the y list, the value of sine theta, or whatever the function that we're computing, and rest of the things are same. We have computed the value of x and y. Right now, if I execute this program, certainly it is not going to show me any output, because we just have computed the value of these lists x and y. We didn't print anything, right? But if I want to print the value, the list x and y, we can easily print. So print x and print y. It'll print both the lists. I mean, the values of x and y is in the form of list. See here, this is your x's, these are y's. Against 0, 0, against 1 degree, this is the value, 2 degree, this is the value, like that. But again, we don't want to see them in this way, we want to see them in the form of a graph. Once you have these x and y's, plotting the graph is damn straightforward. What you have to do is, you just have to write plot, and then we are using the name me here. So me.plot. Plot is a function. Here plot you have to write as it is. Okay, this name is yours. I mean, you can call it anything, but this function that you're calling on that name, it should be the same. I mean, it's just a nickname you have given to this particular library, and on that library you want to call this plot function. Plot, and then you have to write x versus y. It's as simple as that. And after that, you have to write me.show. Okay, this show function you have to call on it, and that's all. It will compute, it will actually plot x versus y. You can see this nice curve is coming. It's as simple as that. You might be thinking, is it really as simple as that? Yes, it is really as simple as that. See what I mean by that. It's not only one function, you can compute the values of multiple functions and you can plot them together on the same plot. Let's see how to do that. Not only sine theta, suppose we want to compute the values of cos theta also. So for that, we need same x, y, we need two values now, right? So one for the same x, one value of sine theta, one value of cos theta. You got it? For the other function. So let's call it, say for example, y2. We could have called it y1, y2, or y2. Say y2 is equal to a blank list, and there what we want to put is, we want to put the value of cos theta. Say we can write like cos is a variable, and then we can write mat dot this cos function on the same angle radian. We can do it in this way, and then we can append this cos at the end of this y2 in this way. I mean, say, okay, let's do the thing with sine first, and then let's do this cos. Cos is equal to this, and then y2 dot append, and then here we can put this value cos. But instead of writing it in this way, two lines, now since people are now familiar with such codes, then what you can do is actually directly you can write something like this: y2 dot append, and there what we want to pass, we want to compute this function mat dot cos theta, whatever it is the value of theta. I mean, in radians we already have converted it, so we can write here mat dot cos dot radian. So this will compute the value of y2. Once it is done, then you want to plot this graph also, so you'll be writing me dot plot, and then now x versus not y, y2, and then plot dot me dot show. So what it will do is it'll plot both these y and y2 against these x, and as a result you'll be seeing this output here. So it is plotting sine theta and then this cos theta. But again, there is this, whenever you're plotting graphs, now if you look at this graph, you don't know exactly like this blue line is sine theta, or this brown or reddish line is sine theta or cos theta. Which one is which one, right? I mean, you might want to give them some names. So for that reason, what you can do, it's simple, but yeah, let me tell you here. I'm just showing you some interesting things. These things you'll be using quite frequently if you are a scientist, and or you are a person whose main job is like science, doing science, maybe biology, mathematics, or whatever, and you need a programming language so that you can actually do computation. You can ask the computer to do some computations on related to your task. Like you want to execute a function, say for example, for many different variables, and you want to see like you want to like do some observation by looking at the values of those functions. So for those people, these things are quite important. Okay, now let's give it a name. Suppose you have plotted it and then you want to give it name. So names are called as legend. So what you can do is simple: me dot legend is a legend is a function, and then you have to specify here a list. I mean, you have to specify like how many graphs you have. For each graph you want to give a name. So we have two graphs, y and y2. We want to give it a name. So y is, the first one was sine theta, and the next one was cos theta. Whatever the names you specify, it will automatically create legends, and it'll automatically create legend, and it will plot it there. See here, you can see that this sine theta and this cos theta is coming here. Blue line is this sine theta, and this brown line is this cos theta, brown or red or whatever it is. Okay, so that's how you can plot sine theta and cos theta. Not only two functions, if you want you can plot like three functions, four functions, like that. Say let's, along with computing sine theta and cos theta, declare here another list. Say for example, y3 is equal to a blank list, and there we want to put here say y3 dot append, append, and then what we want to do is we want to compute the value of sine theta plus cos theta, say for example. So we can write, oh, here we didn't save the value of cos theta, so we have to write it in this way. So this is our cos theta plus sine theta we saved, so we can directly use it. That's one advantage of saving the result in temporary variables. Okay, y3 dot cos theta plus sine theta. Now we want to put this thing also, like we want to plot that y3 also, and we'll be writing here y3, and there we want to plot like sine theta plus cos theta, say. Okay, and let's see the output here. Now it's nice, right? Sine theta, this green line is sine plus cos, blue line is sine theta, and this reddish line is cos theta. If you add this blue and red, you should get this green. Got the point? Anywhere you just take the values of this point plus this point is actually should be this point. Okay, if you have understood up to this point, then let's move one step further, and let's try to do something more interesting. What is more interesting is like, say for example, now we want to plot a circle using matplotlib. I mean, how do we plot a circle, right? I mean, what is a circle? I mean, see here again, it's just like plotting a graph only, but the graph should look like a circle. That's the main point. What I mean is, say for example here, let's consider a circle like here. Just a second here. Okay, yep, right. I want to use bit thicker. Okay, let's consider a circle of radius r. This is the center of the circle, or maybe this is the circle and radius is r. This is your x-axis and this is your y-axis. Okay, and this is your center and radius is r. Now if I give you any point here, this particular point, what is the coordinate of that point? What is it like? Now we know, like say it is x comma y, but what is this x and what is this y? Okay, if we know like x and y, then we can just replace this point by this one and then this one, and at different angles. See here, this x and y, it depends on the angle, this particular angle theta here, isn't it? Like theta goes from, for this point theta is 0, maybe this is 1 degree, 2 degree, 3 degree, 4 degrees, like that. Got the point? So these x and y, it depends on theta. And what are those values? So we know like x coordinate is whatever it is the coordinate, I mean the radius r, then sine theta, and whatever it is y coordinate is like r cos theta. It is as simple as that. We know x and y in terms of sine theta and cos theta. We can represent it if we know the angle theta. Now if you want to plot the entire circle, then what we have to do is we just have to compute the value of these x and y's for different angles. Like you can compute it like 1 degree interval, so you can plot it and you should see a circle. Let's try to do it. Okay, not this code here. Yeah, let's try to do it. We already know how to print the values of sine theta and cos theta, so we just can change the program here and we can do the thing. But let's since we are learning things, let's again do it from scratch. So what we want to do is that we want to grow from again 0 degree to a complete round 360 degrees. So we'll be writing c is equal to, we'll be like starting at 0, and then we'll be computing while the value of c is less than equal to 360 degrees. We want to do something here. Okay, and let's now declare, we need two lists because we want these x coordinates to be remembered, y coordinates to be remembered, and so that we can pass them to the matplotlib function. Okay, so what we can do is, okay, let's call x is equal to a blank list and then y is equal to a blank list, and then inside the block of like body of the while loop, what we want to do is c is equal to less than equal to 360 degree, less than or equal to, we want to go up to 360. Then we want to compute these r, right? I mean these things, x and y's, right? So let's compute these x and y's. X is equal to okay, so x1, let's call it x1 is equal to mat dot, see this time I have not imported because it is already imported there, but if you have not, then again let me do it for practice. So you have to write import mat, that's all. You can give a small name, but already the name is very short, so you can use mat directly. And then also we'll be plotting graph, so for that reason you'll be writing import matplotlib dot pyplot, as you can give any name. So typically I give plot, so I'm calling here this time plot. Okay, and okay, those are libraries that we'll be using, so we have imported. Now mat dot, we want to compute the value of sine theta, but theta we cannot write as it is, so we have to compute the radian. Mat dot radians of whatever it is the value of c, we'll be converting it to radian, we'll be passing it to sine theta, and that's all. Now we want to set the radius of the circle, so we'll be declaring a variable r and we'll be setting this value of r to some value, some radius. Okay, say for example 10. So this time this x1 we have to multiply it by, yes, the radius, right? And same thing we have to do for y1 also. Only difference is that this y will be mat dot, not sine theta, this time this is cos theta. So you know the x and y's. So if you know x and y's, then you just can plot it using matplotlib. So plot, we are using plot because I'm writing here, because you see this name I have written here plot, so I'm writing here plot dot plot. This is the same function that I used previously. Plot dot plot x1, sorry, now x versus y, but we have not computed x versus y, right? I mean our x's and y's are blank. So what we want to do is this x1 and y1, we actually wanted to push it into the list, a corresponding list. So x dot append x1, same thing we want to do, I mean y1 we want to append append at the end of the list I. So here will be y1, right? Yes, as I guess people are understanding. Plot dot plot x comma y, and then plot dot show. Okay, and done. Let's see what output it gives you. It should give you a circle. Oh, I'm sorry. The same mistake I did here. You see, I just ended up writing an infinite loop. Can you recognize the problem? Now see, the program is getting executed again and again and again. For the same value of C, initially started with 0, we never have changed the value of C. That's a mistake. Yeah. So we have to stop it. Yes. And then what I'll do is I'll correct my mistake by writing C is equal to 1 degree at a time. C is equal to C plus 1, and done. Let's now execute the program. You should be able to see a circle. You might be thinking, no, this is not a circle. This is an ellipse. No, it's a circle. Only thing is that image is, and the shape is sort of, you can see it is from -10 to +10, and image is deformed. Okay, deformed was the word I was looking for. But it is saying, say -10 to +10, -10 to +10. Basically, it's a circle, but it is stressed a bit. It's using different dimensions. So if you want to fix the problem, you can do it in this way. So what you can do is, this entire thing is actually represented by a figure object. If it is not clear, don't worry. I mean, these are some typical things that we will be doing usually. Just fix those issues. It's not directly related to the programming that you are doing. Your programming is this part. Computing the values of x1 and y1, knowing like how to compute them for all these different degrees. That's your contribution. The rest of the things are like, it's everybody has to do the thing that way only. If they have to plot a graph using matplotlib, always you have to write something like this. You want to set the dimensions, you'll be doing something like this. Say for example, f is an object. From this plot you have to get this figure, and this is the standard approach. And then writing f dot set underscore figure width, and you have to specify the width in terms of inches. Say for example 4 inches, maybe automatically it will be considered as inches. Okay, you don't have to specify, write explicitly anywhere that it is in inch. Set figure height, height, 4 inch, then it will be a circle. If you write 4 inch, here it is now 4 inch, maybe here it is different. That's why it is deformed circle you are seeing. So if you set the dimensions proper, you should see a proper circle. But it's not a circle yet, because I did this thing. I have to do this thing before plotting actually. Plot.show, maybe here I have to do it, and then let's see. Oh, I'm sorry, I have to get this. Okay, I'm sorry. Okay, now let's see the output. Still it is not. Why? Okay, I have to do. First I have to set the height and width, and then I have to plot. Okay, so that time you will see a proper circle. 4 inches here. So if I write here, say 7 inches and 7 inches, then also you'll see a circle, but it's a big circle. But if you give, say for example, this is 4 inches and this is what is 4 inches, width is 4 inches, height is 7 inches, so you'll see like an ellipse in this direction. That looks like an ellipse actually. Got it? Okay, then that's all about while loop. Our story began with while loop, and see here still it is, although our main goal was to display a circle on the screen, but see this for loop played an important role to do that thing actually. Without this for loop, it would have been very difficult to plot this circle. I mean, if you have to write manually every time you want to compute, you can, but the thing is that from 0 to 360 degrees, 360 times you have to write these x1 and y1 and x dot append, y dot append. That's not possible. I mean, difficult, right? So that's the power of a loop actually. And that's all for today's video. I hope you people have learned something. You got some value out of this video. And if you like this video, please press the like button, subscribe to the channel if you're interested in such contents, and share the video with your friends. Okay guys, then see you in the next video with some new content. Till then, have a nice day.